All right, welcome back to lesson 3.4 on factored form. Figured we'd just take a quick little break there in between videos, try and keep them a little shorter for you. So, in our first video, we learned how to find x and y intercepts when a quadratic relation is in factored form. Well, now we're going to explore a couple other things here. Recall that a parabola's vertex lies on its axis of symmetry. AOS. The axis is midway between any 2 points that have the same y coordinates, such as the x intercepts. So, as long as y is the same, those 2 points, all we have to do is add those two x values together, divide by 2, and we've got our x coordinate point for our vertex. So, what we're going to do, since we've got it in factored form, we're going to actually use the factored form to help find the vertex. So, the x coordinate of the vertex, hk, so that's our vertex, hk. Our x coordinate of the vertex is h, described by the relation y equals a times x minus r times x minus s, is found at h. I'm going to actually write this down here. H equals, in brackets, r plus s divided by 2. So we just take our two intercepts, x intercepts, add them together, divide by 2, and that's going to tell us our x coordinate point of the vertex h. Once we've got that, the y coordinate is at k equals a times h minus r. Let's just scroll down a bit so you can see that. And h minus s. And that's going to give us our y coordinate of a vertex, also known as k. So we can use these formulas from factored form to find the vertex. And if we know the vertex and we know the x-intercepts and the y-intercept, we can roughly sketch out the quadratic relation. So, let's try it. Determine the coordinates of the vertex of the parabola described by y equals 3 times x plus 2 times x minus 4. So the first thing I like to do is state what we know. And what we know is r is minus 2 and s is positive 4. Remember, r and s are the opposite signs of whatever's in the brackets here. So r is minus 2, s is positive 4. So if we want to find the h coordinate of our vertex, or the x coordinate of our vertex, we're just going to add r and s together and divide by 2. Find the average of them, or the midpoint. So I've got the formula here, h equals r plus s divided by 2. And we're just going to fill that in now. I'm just going to switch over and add fractions in to keep it nice and pretty. So r is minus 2. We're going to add that to 4. And we're going to divide that by 2. Minus 2 plus 4 is going to go to 2. Let's just toss that back in here. Fraction, perfect. Our numerator is 2, our denominator is 2. So h is just going to be equal 1. So that's our x coordinate point. H equals 1. Now, in order to find k, which is our y coordinate point at the vertex, what we're going to do is follow this formula. Well, the other thing that we know is that a is 3. We see that right in our equation here. So, k equals, instead of a, we've got 3. Instead of h, we've got 1 minus, let me just scroll down here. R is minus 1, so We're just going to put that in. Sorry, minus 2. For our first bracket, we've got 3 minus minus 2. And then h minus s is going to be 1 minus 4. We're going to simplify and then multiply. So order of operations tells us always do our brackets first. 1 minus minus 2 is the same thing as 1 plus 2, so that's going to be 3. 1 minus 4 is going to be minus 3. So k is going to equal 3 times 3, which is 9, times negative 3, which is going to be negative 27. So our vertex is at point 1, negative 27. Once again, if you want to make sure that you're correct, if you want to do a check, if you're doing this on a quiz or an assignment, you can simply put the equation into Desmos and then look at what the vertex is. It should be the same. So y equals 3 times x plus 2 times x minus 4. Put that in just like it is into Desmos, and it'll verify what your vertex is. All right. Once again, another one here. Graph the quadratic relation y equals negative, in brackets x minus 3, in brackets x plus 5. So once again, we're going to go through what do we know? Well, r is positive 3, s is negative 5, a in this case is negative 1. And so if I want to find my vertex, because I know my x-intercepts, but I need my vertex to really be able to graph this, I'm going to go h equals, and this time I'm not going to put it into a nice form. I'm just going to do 3 plus, oh, k is minus 5, or get my terms right, s is minus 5. So 3 plus minus 5. And all that's going to be divided by 2. In this case, h minus, or 3 minus 5 is going to be minus 2. That's divided by 2. And so our h point is minus 1. Now all I need to do is find my k value. Once I have my k value, I can now do a rough sketch of the quadratic relation. So a minus 1 times h is minus 1, r is 3, so minus 1 minus 3, and h minus s is going to be minus 1 minus minus 5. Once again, simplify, and then once we've simplified, we can find out what k is. So minus 1 times minus 1 minus 3 is minus 4. Minus 1 minus minus 5 is positive 4. So negative 1 times negative 4 is going to be positive 4 times positive 4. K is going to be 16. So our vertex, which we now have, is at negative 1, 16. Down here, I've got a little graph. I don't think it's going to go all the way up to 16. So actually what we'll do here is I'm going to put that. So if I had to go negative 1, oh, that's 1 to the left, and then up 16, 2, 3, 4, 5, 6, 7. We need to double that. So we'd be up somewhere around here. So our vertex is going to be somewhere way up here. Our x-intercepts, if we remember, are at R and S. So x when x is 3 and y is 0, and when x is minus 5 and y is 0. So we can do that. Minus 5, 0, 1, 2, 3, 4, 5. There we are. Positive 3, 0, 1, 2, 3. And now we can just connect this. And we've got a rough version of our parabola. Once again, if you've got a ruler, I strongly recommend it. I do not, so I'll just do that. And we've got a rough idea of what our parabola